Alright guys, so in this session we will be talking about that 9-day Earth signal mystery, okay, which is solved now. So in September 2023, 9 consecutive days, Earth, was giving some kind of signals and everybody was confused and scientists were perplexed and had no idea, no clue about what was actually going on. A lot of theories and a lot of discussions were there about that. This could have been the reason, that could have been the reason, right? So ultimately, the issue is solved, what was behind that, and everything is discovered, and that's exactly what I am going to discuss in this video. So let's get started. Okay, so the unusual seismic activity, the detection, scientists monitoring seismic activity detected an unusual continuous signal in September 2023. They considered it as some signs of something, right? And the characteristics, if you look at, the signal was low frequency vibration, unlike typical earthquake waves. It's not like normal earthquake waves, but it was low frequency vibrations. And global reach, it reached every corner of the planet from Arctic to Antarctic. Now duration, the signal persisted for continuous 9 days. So that's why it have become very important, and scientists were continuously researching on that, have collected a lot of data, and now came with the conclusion and solved the mystery. So initial theories and speculation, I told you already there were a lot of assumptions and there are a lot of theories which has been brought in initially. So let's look into that. Hidden volcano. Some scientists theorized an undiscovered underground volcano was causing the signal. That's not true. Equipment malfunction. Others suspected a global malfunction in Earth's seismic monitoring equipment because there is no earthquake. And even if you look at the frequency, it's very low also, so it might be because of the equipment malfunction which is used for monitoring the Earth's seismic activity. And then hidden forces, more speculative theories suggested unknown forces at play beneath the Earth's surface. And deepening mystery, as time passed without a clear explanation, the mystery only intensified and scientists had to work on this. So the global scientific response, so international collaboration, over 70 experts from 15 countries joined to solve this mystery. Geologists, seismologists, and oceanographers from renowned institutions across the country, worldwide, collaborated and pooled their knowledge and resources to find out the mystery. So from United States Geological Survey to the British Geological Survey, leading experts came together to decipher the puzzling signal. So a lot of experts have joined hands together to find out this issue. Data analysis, again, if you look into thousands of data points has been checked and cross-checked and matched. So if you look at this, thousands of messages and data points were meticulously analyzed. Sophisticated algorithms were employed to sift through vast amount of data collected from seismic stations across the world, across the globe. Advanced computer modeling helped visualize the signal's propagation and characteristics, provided crucial insights into its source. And I'll come to the conclusion. And the time frame, the investigation lasted for a full year before the cause was understood. Researchers dedicated countless hours to scrutinizing data, conducting simultaneous, simulations, and collaborating on theories. So their perseverance and time ultimately led to the groundbreaking discovery that revealed the true nature of the 9-day signal. So let me now reveal the actual reason for this. So the Greenland catastrophe revealed. The location, the event occurred in Greenland on September 16, 2023. So that September 16 event, and then it was followed by 9-day this activity. That's what we were talking about so far. So it was not detected at that point of time through the contribution a lot of oceanographers, scholars, and checking hundreds of data points across the globe which are available. Then finally they have solved this mystery. It is because of this issue. So the scale, that 500-meter thick slab of rock fell into the ocean. If you look into that, it's huge, it's massive. So much of liters of water has been displaced at a very high speed, right? And that could have created a big tsunami also in that area. Okay, so event type, a massive geological collapse triggered a catastrophic landslide. That led to a landslide and impact. The collapse set off a chain of events, including a mega tsunami. Okay, the magnitude of the collapse. If you look at volume, a fallen rock could fill 10,000 Olympic sized swimming pool. So you can imagine the size of, that thick slab, okay, and the water which could have been displaced because of that fall. And the speed at which the rock fell at an approximately 47 meters per second. Speed, right? Distance, it plummeted about 1.6 kilometers before hitting Dixon Fort. Now the resulting mega tsunami that led to a big tsunami, I told you, when you get this kind of rock falling into the ocean, and that what will happen, this much amount of water will be displaced all of a sudden, that can lead to a higher, big volume of water is going, and that is making a bigger tsunami. Higher, the height wise also it will be very big. So initial impact, the rock crash caused waves to splash back and forth in Dixon Fort, that area. And then wave height, tsunami waves reached an unprecedented heights of up to 650 feet. I think recently this is the highest of, any tsunami. In recent years, if you look at record breaking, this has become the tallest tsunami recorded in the, yes, that is there. It is mentioned here. And global seismic impact, vibrations. The events and vibrations through Earth's crust detected worldwide. That's what we were experiencing across the world from Arctic to Antarctic for a period of 9 days continuously. And the signal reached seismic activity was recorded from Greenland to Antarctica. Duration, the continuous signal persisted for an unprecedented 9 days. All right. And the Seege phenomena. Definition, this has been named by the scientist as this phenomena, Seege phenomena. A Seege is a rhythmic water movement in an enclosed space. A rhythmic movement of water in a closed space, okay, that can lead to the displacement of water, etc. Analogy, it's similar to water sloshing in a bathtub when shaken. That's the analogy. So it will be similar to that. And duration, the Seege continued for 9 days, causing the prolonged signal. Now the climate change connection, how it is connected with climate change. See, all these activities, tsunami, earthquake, and everything is having connection with climate change. So glacier thinning, Arctic glaciers have been losing mass over decades, and it is getting thinned over a period of time due to global warming. And structural weakening, this has weakened the structural support of mountains as well. Instability, mountains have become unstable, leading to events like this collapse. So direct link, the Greenland rock collapse is linked to the glacier melting. So if you look at the direct link over here, what do you mean by glacier melting? That is because of global warming. So when global warming is there, glaciers will melt, that lead to thinning, and that led to that rock collapse here. Unprecedented nature of the event. First of its kind, this climate change triggered event has never been recorded before. That's why that led to a lot of confusions. Okay, and I told you a lot of different theories, discrepant theories have came about that, but none of them could actually explain the reason of the same. And global impact, seismic energy was felt from the Arctic to Antarctic across the globe. Scientific significance, the event provides crucial data for future climatic research. Now local destruction, see, the maximum destruction it caused was in this Ella Island, which is close to that area. So location Ella Island near the collapse site, and the wave height was around 13 feet. So now climate change implications, if I want to add destabilization, climate change is destabilizing earth crust in polar regions. Again, a big concern and issue. Increased risk, earthquake, landslides and tsunami are becoming more likely and more often it is happening. All these are because of climate change. And see, this is because of global warming, glacier melting, it is getting thinned, Arctic regions, and the rocks are getting thinned and rocks are getting displaced and they are falling. Okay, so that displacement is also coming. And future concerns, similar catastrophic events may occur as global temperature rises, which means global warming. If you cannot control, the same situation can come. The fragility of our planet, interconnectedness, the event shows how local changes can have a global impact. See, I told you it touched from one to the other end, Arctic to Antarctic, Greenland to Antarctic, which itself shows how world is interconnected. So any event here can affect there and everything is interconnected. Unexpected consequences, climate change can lead to unforeseen and dramatic events. Urgency, this emphasizes a need for immediate action for climate change. And guys, remember this can be a very important topic this year mains and next prelims. So very important topic that you need to have very good idea of this topic. Can be in mains as well as in prelims. Okay. So research call to action. Continued study of these events is crucial for understanding and prediction. Mitigation. Efforts to slow global warming may prevent future catastrophic events. So that mitigation, prevention is required, mitigation is required, preparation is also required. Improved daily warning system can help to protect vulnerable communities. And global cooperation, international cooperation, collaboration is essential to address these global challenges. That's why we have various conferences for the same, and countries are joining hands together to tackle the main issue that the entire globe is facing, that is global warming. Okay, so that's it guys. Thank you so much. See you in the next session.